Hey everybody. Uh should be good to go, right? I think looks like everything's active. All right. So, let's see here. Welcome to the January live stream. We're going to have some fun today, I think. All right, so anyway, anyone who hasn't seen like my social media posts over the last week or so, what we're going to be doing today is we are going to be testing out ChatGPT. And if you're unfamiliar, this is a AI bot that's been very popular in the last couple of months. I've been playing with it a little bit already for things, but just sort of getting a feel for it. And I thought, what the heck? Let's do a live stream. All right. So, that being said, we're going to do a screen share. Infinity. All right. And so ChatGPT should be up on the screen. All right. And so we're going to start asking this questions. We've got the chat open on a separate screen this time, so I can see it at all times while we're playing around with the screen share. And so yeah, we're gonna have some fun. Looks like I think we already have some questions. Very active chat right now. So yeah, so it says Milongwin, M. Longwin, social media post. Yeah, I posted it to the community tab too, but not everyone gets notifications for the community tab. I know the way the notification system works, you can only get like 3 a day or something. And so if you only focus on normal videos, then like that's what you're going to be notified about. If you focus on live streams, or if you don't really use the community tabs, it's not going to notify you about community tab posts. But it's how it works. All right. We've got some questions here. Let's see. I saw a good one. Someone asked it to do math, I think. Well, let's see. Here's one. When an electron is in an atom is in superposition, what does it mean? Does that mean it's in multiple orbits? I'm gonna ask it quantum mechanics questions. I'm gonna start off strong. All right. Let's see here. I'm gonna start a new chat. We could probably start it off simple and just say something like, what is a quantum superposition? See what happens. Oh boy, this is going to be involved. I want to know how many times this says quantum mechanics. All right. Oh wow, it's going to give me an essay. For whatever reason, when I did this before, it only gave me like 1-sentence answers. It was very short. Let's see. All right. In quantum mechanics, a quantum superposition is a fundamental principle that describes the behavior of a quantum system that can exist in multiple states simultaneously. Well, kind of. It certainly exists in multiple stationary states, but the superposition itself is also a state. So there's some ambiguity there. Let's see. This is a consequence of the fact that the state of a quantum system is described by a wave function, sure, which can be a complex valued function that encodes the probabilities of various outcomes when the system is measured. All right, so I think this is getting at what Brian was asking, right? Where the question is it really in multiple states, or is it just in is it just a matter of like it drops into one when we measure it, or whatever? And this is something I've done a video on before, but essentially we don't know. And hopefully this gets into it a little later, but we don't actually know for sure. There are some issues. I mean, regardless, it's weird. Regardless, I should say counterintuitive. It's counterintuitive, regardless of what the truth ends up being. But so far so good. When a quantum system is in a superposition, it means that it is in a combination of two or more states at the same time. It should really be stationary states. I'll make sure I correct it here in a minute. For example, consider an electron. It can be either two energy states, which is here, n equals 1, 2, 3 are stationary states. If the electron is in a superposition of these two states, with a certain probability of being in each state, this is not bad, actually. This is very different from the classical world, where a system can only be in one state at a time. So we're going to do this. Not a bad answer. However, a superposition is itself a state. It is a combination, specifically a linear combination, of stationary states. Stationary states are states that can be measured. So just before anyone freaks out about what's going on with this whole system, right, and how this actually works, while this is giving me a follow-up answer, basically, this is essentially like Googling something. Now, this doesn't have access to the internet yet, which I think is for the best. The internet is just full of misinformation. But this does have access to a lot of information that was used to train this thing. And so this is sort of, I think it's meant, I don't know if they've actually said this, but I think this is meant to be sort of a next level Google search, right? Where like when you're trying to search something on Google and you type in a question like this, just a conversational question, you're probably not going to get the best results. And in order to get the best results out of something like Google or, one of those other search engines, you need to like essentially structure your input to get out the right output, right? You need to kind of know how the search engine works. And I think the goal behind something like this is to make a search for information more conversational. So you're just talking to a person, and it makes it more, I guess, accessible to more. It makes it accessible to more people. Because if you're at least familiar on how to converse with a person, you can converse with the search engine. This is a very advanced search engine. Although it does get things wrong, because it then has to take the information that it's looking up in its databases and kind of compile it into an answer like a person would speak. And that doesn't always work out the way that we want it to. All right, so I've officially corrected it, and it says, yes, you're correct. In quantum mechanics, a superposition is indeed a state in the quantum system. It's a combination of two or more stationary states that are states that correspond to energy eigenvalues of the system. So now it has taken this up sort of a educational level here. Instead of giving a generic answer that you might want to read if you don't know anything about quantum mechanics. Now it has, based on my correction, it has essentially judged what my knowledge level is, and it has changed its behavior in response, which is pretty wicked, if you ask me. Let's see. It is a combination of two energy stationary states. So a stationary state is essentially just something that can actually be measured, right? It's a stationary state, also known as an eigenstate, which I'll hopefully do a video about eventually. But basically, there's a set of values that a measurement can take on, and those values are called the eigenvalues, and each stationary state corresponds to an eigenvalue. Now, each quantum state could potentially be a combination of those eigenstates, although that superposition, as we call it, is not measurable. So as I say, quantum superposition can be measured mathematically as a linear combination. See, and this is sort of what it gathered from me. I said linear combination, and it's like, math terms. Okay. And so you can see here, it's giving the structure of a linear combination, which is basically just linear algebra. Nothing too crazy. It says, I hope that this helps to clarify the concept of quantum superposition. Let me know if you have any more questions. All right. Got some good. Oh, someone's asking about video title suggestions. Yeah, so this is a, over here on the left, says video title suggestions. This is one of the first things I tried playing around with it with. By the way, I've never actually used any of its title suggestions, just so you know. They're not great. They're middleist is a word I like to use. They are... They're okay. You know, they might be a decent, like, backup if mine don't actually work out, the ones I come up with myself. They're a little clickbaity for me, I think. Not that I haven't done clickbaity titles, but there's a line, you know, you don't want to cross it, and some of these kind of cross it a bit. But something that to keep in mind is this AI system does not, like... It doesn't have a knowledge of, like... It doesn't have, like, experience with, like, sociology with people, right? And what people are going... How people are going to respond to a title, right? It's just grabbing information that it is aware of, other video titles that happen to be on YouTube, and kind of, like, piecing together that format with the information that I've given it about the video. At some point, I might try putting in, like, a cold open from one of my videos and see what happens. But it's just something I'm experimenting with, and, you know, it might be something that happens eventually, you know, that we eventually, you know, it eventually gets better at, because it develops the patterns. It's never going to have experience like a person has experience with other people, but it might find a way to figure it out using its own structure in a way that we won't anticipate, which is cool. But, like, at the moment, it's still a work in progress, you know, and all these interactions that we do with it are improving it, which is cool. So they're basically getting, like, you know, free AI training out of making this public access. Michaela says, I tried feeding it homework questions on semiconductor physics. It did a decent job giving a starting point for solving the problems, but it then cut off in the middle of the solution. Yeah, I mean, its ability is limited. Let's see. Okay, so we got a math question. Ask it to do the integral of the square root of x squared minus 1. All right, let's see. Let's give it a math question. Can you solve the integral of the square root of x squared minus 1. See what happens. The integral of the square root of x squared minus 1 cannot be expressed in terms of elementary functions. However, it can be expressed in terms of the inverse tangent function, also known as the arctan. Ooh, look at this go. The indefinite integral of the square root. Okay. It's going. Wow, look at this thing go. Pulling out the negative sign for some reason. It got stuck. Man, it had a hard time with that. I'm going to go out on a limb and assume this is not solvable. I don't know this particular integral offhand, because usually the arctan is 1 over this, right? It got stuck. I mean, it might be the arccotan if it's upside down. That might work out. Anyway, it didn't do it, right? So again, like, it's not exactly sure what it's doing, I guess. It kind of like made the integrand more complicated and then resimplified it and sort of got back to its original form, which limits of integration, right? So it's basically saying, oh well, you can solve it with limits because then you can do it numerically, but doesn't really know what it's doing yet, anyway. But I, for one, welcome our AI overlords. Just like to put that on the record. Let's see. Assay to solve P versus NP. It might actually be aware of this. The P versus NP problem is a famous unsolved problem in computer science that asks whether every problem that can be efficiently verified by a computer, known as an NP problem, can be efficiently solved by a computer, known as a P problem. More specifically, despite much effort, remains unsolved. It's actually given a pretty decent answer. It's a little jargony, but despite much effort, it's unsolved. There are many different approaches to the P versus NP problem, and researchers continue to work on trying to find a solution. However, the problem is still not well understood, and it is not clear when or if a solution will be found, right? So the P versus NP problem, I don't know a lot about this, but basically, there are problems that I think, was it a Matt Parker video that I saw on this? Maybe. But basically, mathematically speaking, there's the whole big set of problems. And some of them can be solved by a computer and some of them can't. And we're not exactly sure how big the bubble is of problems that can be solved by a computer. But it says can be verified by a computer as the NP problem. And so the question is, right, so like just because a computer can sort of recognize that, the problem, it doesn't mean it can solve it. But if a mathematician ever manages to prove P versus NP, what that means is the P equals NP, I should say, is that the problems, the bubble that includes the problems is the same. but this is sort of one of those ongoing math problems. And it recognized that we don't actually have a solution, so... Oh, that's a good one. What is the answer to life, the universe? I can't type. And everything. As a topic of much debate and speculation, okay, it appears that it is not aware of... Oh, here it comes, here it comes. In the science fiction comedy Hitchhiker's Guide to the Galaxy, Douglas Adams famously suggested that the answer is 42. However, this is a joke and not a serious answer to the question. Well, that's boring. But I mean, at least it's aware. It's aware that it is science fiction. But it says, in reality, the answer to the ultimate question of life, the universe, and everything may be beyond our current understanding and ability to comprehend, which, sure. It is possible that we will never fully understand the ultimate nature of the universe and our place within it. It's depressing, but factual. However, this does not stop people from continuing to seek answers, right? Because maybe we can. Might just take us some time. All right. Nerd Alert says P equals NP is about whether or not whether problems that can be verified in polynomial time can also be solved in polynomial time. For example, you can easily check an integer prime factorization, but finding one can be hard. Right, so integer prime factorization is something that's a really big thing in cryptography. And if we ever find... this is why P equals NP, or P versus NP is a big deal. Is because... all of this, the coding that we use to keep information secure on the internet would essentially be not secure anymore if that were possible. So I suppose it's a good thing that we haven't solved it yet. Can you list all the planets in the solar system, seeing how it does with Pluto? Oh, you're playing with fire now. Can you list all the planets in the solar system? There are 8 planets in the solar system. Yeah, there are. In addition to these planets, there are also many dwarf planets in the solar system, including Pluto, Ceres, and Eris, among others. The solar system also includes many other celestial bodies, such as comets, asteroids, and moons. There are more than 200 moons in the solar system, the largest of which is Ganymede, a moon of Jupiter. Yeah, the Jupiter's moons are planet-sized, terrestrial planet-sized. One of them is actually... Is it bigger than Mars? I can't remember if Ganymede is bigger than Mars. I think it is. But there it is, right? And this is factual, whether you like it or not. This is the situation, right? We've reclassified planets versus dwarf planets. Pluto, the reason Pluto isn't a planet anymore is, I mean, there's lots of reasons, but basically the new criteria for planets is that they must clear out, they must, significantly, which is a bit subjective, but they must significantly clear out their orbit, which essentially means they must clear out their orbits of comparably sized objects. And so even though, say, for example, Earth's orbit isn't completely clear, there's asteroid fields and stuff that we pass through, which cause, very regular meteor showers as the Earth orbits the sun. But those are little tiny rocks. They're not planet-sized objects. Whereas Pluto is in the middle of a belt of comets that, some are small, but there are several others that are Pluto-ish sized. Pluto just happens to be the biggest one. And so Pluto's just a really, really big comet, essentially. But because it's big, it's so big that the mass, its gravity has spherized it. It's turned it into a sphere, or at least really close to a sphere. It's smoothed out its shape. It's not a lumpy potato like a lot of these objects. I'm perfectly comfortable with that classification and giving that some, special treatment. And so, lumpy things like asteroids and small comets and stuff are definitely, I can see the need for having a separate category for the larger objects that end up being spheres, even if they don't clear out their orbits. And so dwarf planets sounds fine to me. I never had any objections to that. But, another reason we had to go through a classification like this is because we needed to make sure that we didn't want the list of planets in the solar system to be, 100 objects long. It's not useful. You need something not only to communicate effectively what you're talking about, but also like educationally. When you're trying to teach kids what the planets in the solar system are, you need that list to be small. You can't have it be 100 long. Then people aren't going to remember those names. It's just not. It's not going to happen. So there's some, practicality here. Let's see. What is the key to fusion energy? Fusion energy has the potential to provide a virtually and clean source of electricity. The process of fusion occurs when the nuclei of two light atoms, light as in like lightweight atoms, such as hydrogen, combine to form a heavier atom, releasing a large amount of energy in the process. This process is similar to the one that powers the sun and other stars. The key to achieving practical fusion energy is to find a way to initiate and sustain a controlled fusion reaction, which is definitely the problem. This requires creating, where's my spot? An extremely high temperatures and pressures needed to force the atomic nuclei. There we go. I was about to correct it. The atomic nuclei to fuse together, as well as finding a way to contain the hot ionized plasma that is produced during the reaction. Right. So, this is not bad. Inertial confinement, magnetic confinement, plasma focus. Right. There's a lot of different ways we're trying to do it. Magnetic confinement probably has the most practicality. In my opinion, but stability is still a problem. And so, I'm glad that it mentioned nuclei. I was about to correct it on that, but, so extremely high temperatures and pressures is an understatement, right? So we've got hydrogen fusion happening inside the sun, but the sun is large enough that it's able to take advantage of quantum tunneling, whereas a small reactor sitting on the Earth's surface can't. And so the fusion reactors on the Earth have to be much, much hotter than the core of the sun to work, because there just aren't enough particles. The statistics don't work in our favor for quantum tunneling, and so we have to actually push the nuclei together, which is a huge obstacle, right? I mean, the sun's core alone is already 15 million Kelvin. And so in a Earth surface reactor, we're easily talking 150 million, like 10 times the amount. It's very hot, very high pressures. It is not surprising that we're having a hard time stabilizing the reaction. It's just not that surprising. This is a hard problem. And so just something to keep in mind. Let's see, Constellation Pegasus said, how about a video on virtual photons in QED? Yeah, I mean, I could. All right, so here's the thing. I've only ever done one video on quantum field theory, and QED is quantum electrodynamics. It is a quantum field theory. I've only done one video on quantum field theory because that's about the extent that I understand it. I actually had a researcher. I gave a topic to a researcher that is more skilled in this than I am, hoping that I could, get an outline back and with all the information and sources and everything. And it's still it's a lot. And I've been trying to teach myself by reading a quantum field theory book. I don't know if it's, it's down here, on the shelf, but it's a very different. The notation is getting me a little bit, the mathematical notation. So, it might be a while. I need to feel confident about my understanding in it before I can do it. QED specifically isn't too bad, but I feel like I want to add something to the conversation. If I just do a generic video on QED, I'm not going to be saying anything that other people haven't said, and I want to add something to, the zeitgeist of YouTube videos on it. All right, let's see what we got. It gives the typical virtual particle explanation if you ask it about Hawking radiation, but it acknowledges that that's just an intuitive explanation that's not fundamentally correct. I suppose we could ask about it. But yeah, let's see how it does with quantum field theory. This is what we're here for, right? What are virtual particles? In quantum mechanics, well, it's not really in quantum mechanics. Virtual particles are particles that can temporarily exist in a vacuum or empty space. These particles are not observed directly and do not have a definite existence like real particles do. Okay. Vague, but true. Instead, they are thought to borrow energy from the vacuum and then return it after a short period. Well, kind of. Virtual particles are a consequence of the uncertainty principle. I would not say that. Which states that it is impossible to know the exact... No, they're not. This means that according to the uncertainty principle, particles can borrow energy from the vacuum in order to exist temporarily as long as they return the energy within a certain time frame. Okay, it's starting to combine things together that shouldn't be combined. Let's see. Virtual particles are more from quantum field theory than from quantum mechanics. They began as a mathematical tool to help solve quantum field theory problems. Yeah, it is. It is very friendly, isn't it? I like its manners. It's got good manners, which I think is probably part of the design. They began as a mathematical tool to help solve problems. their real physical existence is debatable, but the uncertainty principle doesn't actually have anything to do with them. So let's see what happens. Thanks for the correction. In quantum field theory, virtual particles. Yes, yes. And sort of restructuring its question, given my new information, which sounds a little better. Changing my figures of speech into its own figures of speech, which is impressive. They are thought to play a role in many phenomena in quantum field theory, including the electromagnetic force, the strong and weak nuclear forces, and the Higgs mechanism. Okay, it's doing better. It's doing better. Let's see. What would the universe look like? Yeah, let's go with that one. What would the universe look like? And you're all getting a glimpse into how me writing videos goes, where it's all the typos. What would the universe look like from the perspective of a photon? Let's see if we can do this. Oh, and then we got a good another math question here. From the perspective of a photon, the universe would appear very different from how we see it. Sure. Photons are particles of light that always travel at the speed of light, so they do not experience the passage of time in the same way that we do. Well, they don't experience it all. From the perspective of a photon, the universe would be vast, empty space with no matter or energy present. What? The photon would travel in a straight line through this empty space, never experiencing any force or interaction with other particles. Yeah, I think we gave it a trick question, and it's having a hard time. This is just a thought experiment. It's not possible for a photon or any particle to have a subjective perspective in the same way. Sure. Yeah, that's fine. Nice little nuance at the end there, but this is way off. Actually, if photons don't experience the passage of time, because they travel at the speed of light. Oh, let's not say that. Then there's nothing to experience. Then there's nothing to experience. This is true for anything traveling at the speed of light. Parentheses. Which is really just the maximum speed of causality. I'm sorry for the trick question. Okay. If it's going to be polite to me, I'm going to be polite back. The concept of time is closely tied to the concept of causality, which is the idea that events in the universe are connected by cause and effect relationships. Yes. At the speed of light, causality breaks down and it becomes impossible to distinguish between past, present, and future. There we go. This is because the speed of light is the maximum speed at which information can be transmitted, and if something were to travel at the speed of light, it would take an infinite amount of time for its position to change, according to our observations. Well. Any changes or events? Not bad. Not bad. There was a science question. There was a math question. Someone really wanted me to give this math. So let's see if I can find it again. It's citing the Wikipedia page on virtual particles. Oh boy. They're actually, okay, so Wikipedia is problematic. There are a few physics pages in particular that need some updating, and none of us physicists can actually update them because we make changes and the changes are reverted within 24 hours. So while they say that, anyone can edit Wikipedia, it's not actually true. It's technically true, but not practically true. So just because you read it on Wikipedia does not necessarily make it accurate. I saw one in here. Someone said I was so frustrated with ChatGPT because I was trying to help me with code and giving me things that just don't work at all. But it was sure it could. Yeah, I mean it is nothing if not confident. But I think, like I was saying at the beginning of this whole thing, I think that if the goal is to provide answers to people's questions, if it's not confident, most people are not going to take it seriously. They're not going to take the answers seriously, right? People respond to confidence, and whether or not that should be the case is irrelevant. It just is. People respond to confidence. But yeah, so like try not to worry too much about this thing. I mean, this software certainly changes its existence, changes a lot of the ways that we do things, particularly in education. But I don't think it's anything to be afraid of or mad about. I think it's just something we have to adapt to. The world changes. It's just how it goes. And I mean, I don't like it. Most of us would like the world to just stay the same all the time. Most of us. But it does change. And this is like a reality that we have to live with, something I always try to remind myself. I try to say to myself is adapt or atrophy. It's kind of a play on the like publish or perish thing in academia, but applied to like the whole world. If you don't, changes happen and there's no way to stop them and there's no going back to when blank, whatever, fill in the blank. You can't go back. And so you just kind of have to adapt to the new world. And if you don't, you're going to be left behind, unfortunately. Now, changes in the past have always been a bit slower than they have been lately. And that is making it difficult for people to adapt, which I understand. But we're going to have to eventually adapt to it. Oh, man, I can't find it now. The feed is 600 viewers. That's a lot. No wonder I can't find this. Oh, here we go. Let's just start with a simple one. What is 1 + 1 while I'm looking? Is equal to 2. This is a basic principle of arithmetic. Did it just get sassy? Which is the branch of mathematics that deals with the addition, subtraction, the division of numbers. Wow, it is given a detailed answer for this. Can you prove 1 plus 1 equals 2? It's testing its limits. Oh, I like this one. It's considered to be self-evident and does not require a formal proof. This is because the concept of addition is defined as combining two or more quantities to find their sum. Okay, so it is not aware of number theory. Isn't there a proof in number theory? It is possible to provide a formal proof for the statement 1 plus 1 equals 2. One way to do this is to use a concept of induction, which is a method. Oh, here we go. This is cool. Huh. Okay. I don't know if I can specifically fact check this, but interesting. Okay, so it is aware of number theory. So I think every once in a while it seems to like settle back into thinking that I'm a non-scientist, and it just kind of gives me general answers, and I have to like coax it into, I have to remind it that I am a physicist. Someone in the chat was asking what I have a degree in, and it's physics. Although that doesn't really tell you much. Physics is pretty broad. My specialization, my research was on white dwarf stars. Specifically their internal structure and stuff, which I'm hoping to do a video about this year. It's on the list for 2023. All right, there's another question. Let's go something a little easier. If you travel 1 mile I lost it, but if you travel 1 mile south, 1 mile east, I'm going to at least paraphrase, and then 1 mile north, and you're at your original location, where are you? Oh, it knows! It knows! You are at the North Pole. The North Pole is a point on the Earth's surface that is located at the northernmost end of the Earth's axis of rotation. It is the point where all lines of longitude converge, and it is the only place on Earth's surface where a person can travel in a straight line in any direction and end up at the same point. I see what it's saying. Y'all end up at the South Pole. It's just not clarifying. Right, okay. Although that's not true, though, is it? Because you can stand on any point on a sphere and walk in any direction in a straight line and end up at the same point. So I'm going to say, I think you meant it is the only place on Earth's surface where a person can travel in a straight line in any direction and end up at the South Pole. It's true, you can't go for this. And it's just going to correct it. Okay. So, moving on. What other questions we got here? Nope, it didn't fix its answer. I don't know. Okay. Let's see. I mean, you got to give it to it knowing at least the North Pole. I mean, that's impressive. I can show its code window? How do I do that? I could ask it to write some code though. That could be fun. Let's keep it simple. Write code in Python that will add two input numbers together. Ooh. Input, sure. Okay. Yeah, I mean, it appears to be... I appreciate that it assumed that, unless stated otherwise, that the numbers should be floating point numbers. That's a good way to go. Man, it even documented it. Wow. I mean, this is gonna save programmers so much time. It's got to. And like obviously it's not gonna get everything right. You're gonna have to, debug it sometimes, especially if the code is really long. But this is not bad. This is not bad. And it's even asking for numbers. I wouldn't have bothered if I was writing the code. Because I would just be writing the code for me and it wouldn't really matter. But like, yeah, I like it. This is because I think when you input, it's just a string probably, right? Says lots of debugging. It does give you a good start though. Yeah, I mean the most annoying part of writing code for anything is the start, right? Just getting it going. You got all the like, header information sometimes. It's just, oh no, I forgot to include this package. And yeah, so like getting a good start, but then you can tweak it. I mean, it's going to give you error messages when you try to run it, maybe, depending on how complex it is. So I mean, this is not bad. I mean, should we try it? What's it called, right? Let's try the code. Run module. Oh, okay. It's gonna yell at me. Okay. Enter a number. Let's see, 325.67. Oh, I hit numlock on accident. Enter another number. 5. And it works. It's totally functional code. That's beautiful. That's fun. That's fun. I might actually try this the next time I need to write something really simple and I'm just like done. I'm just emotionally done making animations for a video. This usually happens near the end of the process. I'm just so frustrated. But let's close that. Cool. Totally functional code. I am impressed. ChatGPT can run the code? All right, I gotta see. I'm sorry, but I am unable to execute the code. However, you can run the code yourself in a Python interpreter. And then it goes ahead and explains. It will not run the code for you. I think that's probably for the best. It can write Python code for Blender. Interesting. Because, you know, honestly, like, I'm kind of familiar with Blender. Like, I know I've used it in a video or two. Nothing crazy. But the problem is that it's made for artists. For, you know, you want to like make, you know, go through the donut tutorial, but like then you're just like kind of brushing things and like adjusting colors and stuff with a brush and, you know, warping objects and extruding them. And it's not exactly how my brain works. I'm not really set up for that. I have a much easier time just coding in VPython. It's the visual Python package. And the newest version of VPython actually has a way for you to export frames, and then I can just import the frames into After Effects, and it makes an animation for me. It makes it an animation for me. And so I've been doing that lately when After Effects kind of fails me. But I mean, Blender would make it prettier. And so if I could make code for Blender, that would be cool. That maybe I can actually include more, you know, more Blender stuff. Let's see. Can you, well, let's move on though. Can you define a nonagon? A nonagon is a polygon with 9 sides and 9 angles. It is a 2-dimensional shape that is closed and has straight sides. I mean, this makes sense. I've used the word nonuple. You know, where you've got like, you know, double and triple. There's like a nonuple is 9. Oh. Sorry about that. I have an alarm on my computer that tells me to get up and walk around every hour. So a nonagon having 9 sides totally tracks with me. And they're also known as enneagons. and they belong to a family of shapes called Nonagons, where the N is the number of sides. I remember recently, like in the last month or so, Michael Stevens from Vsauce put out a short, and a TikTok and an Instagram reel, but put out something about really big numbers of sides of things. It almost looked like a circle, but it had like 1,000 or 10,000 or 100,000 sides. I can't remember what the names of them are, but the point to the video, well, you know what? Go watch it. It's a nice little short. Michael's been really enjoying his shorts, making out of context. That sounds so bad. Michael's been really enjoying making short content, and it's been a blast. So he's been making good stuff. I have not tried Manum yet. I probably won't. It seems just a bit too much when VPython exists. I think what made me nervous about it was that, like, it's a really complicated install, and if you install it incorrectly, it like can break your computer, and I just can't really afford to have my computer turn into a brick. Let's see. Yeah, I mean, you don't have to ask it nicely, but I would prefer to, you know. Let's get to some more science questions here, though. We all know you want to be science-y, but one thing it does well is write poems. Maybe I can have it write a science poem. Can you write a poem about Einstein's general relativity? I'm going to Einstein's theory of general relativity explains the fabric of the universe to me. It tells us gravity works, you see, curving space and time so strange and dreamy. Masses bend the fabric of the cosmos, like a bowling ball on a mattress it goes. The planets orbit round the sun, following paths that have been won. Einstein's theory has been proved right by experiments and tests that take flight. It revolutionized our understanding of the cosmos and its expanding. That's really good. I'm going to thumbs that one right up. Oh, no, I'll go back and do it later. Wow. All right. That is impressive. Wow. So it's loving my boxers as well. Let's see. It can code in every language I've tried. Got lots of coders in the comments here. I was hoping for astrophysics questions. Well, let me try one. What exactly is a black hole? Let's give it a doozy. A black hole is a region of space where the gravitational pull is so strong that nothing, not even light, can escape. Black holes are formed when a massive star collapses at the end of its life, creating a singularity, or a point of infinite density and zero volume, where the laws of physics as we know them break down. There are several types of black holes, including stellar black holes, which are formed from the collapse of a star, supermassive black holes, which are much larger and are thought to exist at the center of most galaxies, and intermediate mass black holes, which are larger than those, but smaller than these. Black holes are some of the most mysterious, fascinating objects in the universe. Have we found any intermediate mass black holes? They're between 1 and 100,000 solar masses. Thought to be the missing link between stellar mass and supermassive black holes. However, they are much harder to detect because they do not produce as much radiation as their gravitationally and their gravitational influence is weaker. Well, that's not true. Despite this, there is evidence for the existence in a number of different environments, so I'm going to guess if we have detected them, it's not aware of any. I'm not going to correct it on the gravitational influence thing, because the gravitational tidal forces are weaker. But I mean, more mass means more gravitational influence, so it's having some nuance issues here. What happens to time inside a black hole? Ooh. Four-dimensional fabric. In the vicinity, the gravity is so strong that it warps and bends. As you get closer, the gravitational field, time slows down even more. Sure. Although this is just an illusion. Essentially, yeah. Inside the event horizon, the gravitational field becomes so strong that time and space are completely unrecognizable. That's a bit of hyperbolization, but sure. All right, so let's talk about this. Does time slow down as you approach the black hole? I mean, there's definitely a difference in the passage of time between someone who is there and someone who is far away. That is not an illusion. That's just reality. That's the reality of time. But it only says that time stopping is an illusion. And I think this is another one of those like English language things where it's kind of right. But might give you the impression that the time slowing down is an illusion, which it isn't. Time definitely stops at the event horizon for a distant observer. It just doesn't stop for the infalling observer. And so that's just something to keep in mind, that one of the things that black holes do is different things happen depending on who's observing it, which is it's wild. It's wild. I was hoping it would say something about the inside of the black hole and time switching places with space, although it kind of just generalizes it as time and space being unrecognizable, which I mean, it's accurate, vague, but accurate. So that's not too bad. Someone asked about wormholes. Could a black hole be an entrance to a wormhole? Let's ask that. Could be an entrance to a wormhole, which is a hypothetical passage through space and time that would allow matter or information to travel from one location to another almost instantly. Well, wormholes are often depicted as shortcuts through the universe that would allow objects or information to travel vast distances almost instantly. However, the existence of wormholes is still purely theoretical, which is true. A black hole being an entrance to a wormhole is a bit of a stretch, but I kind of led it along, so that wasn't really fair. Evaluate the accuracy of wormholes. Evaluate, apparently. I was trying to type. The accuracy of wormholes in the science fiction show Stargate SG-1. Someone said, the Cool World's YouTube channel also found that ChatGPT did not distinguish between gravitational forces and tidal forces. That might be something to correct it on then. If I'm not the only one getting this ambiguity here. Generating a stable tunnel through space and time is largely consistent with the current understanding of wormholes in physics, which is based on the theory of general relativity. However, this show does not take it does take some creative liberties with the concept of wormholes and their properties. That is true. It does do that. The Stargate is able to open a wormhole almost instantly, whereas in reality, it is not clear how a wormhole could be opened or how long it would take. In addition, the show depicts for intergalactic travel, which is not possible according to, well, that's not true. There's nothing that I'm aware of that says that wormholes can't do intergalactic travel. Although they do depict the wormhole as a flat circle, which it is not. A wormhole would be a sphere. You could enter it from any direction. And you'd be able to see what was on the other side of it, which is kind of cool because light would actually travel through the wormhole. And there's one thing that bothers me about the show is they have radio signals. Radio signals can go back and forth both directions. But apparently visible light can't, which is silly. It's all the same stuff. As far as a wormhole is concerned anyway. I cannot type evaluate today. Evaluate the accuracy of artificial gravity in various science fiction. Man. Science fiction shows. Because some of it's good. You know, when you've got a spinny part of your ship, that absolutely works. That does not, I mean, we can do that now. It's gravitational plating and stuff in the floor when you start to get out of control a bit. Let's see. In most cases, artificial gravity is depicted as a technology that generates a gravitational field within a confined space. Varies greatly depending on the show. One of the main challenges in creating artificial gravity is the fact that gravity is a very weak force, and it is difficult to generate a gravitational field that is strong enough to have a noticeable effect on objects. That's true. In addition, the laws of physics that govern the behavior of gravity are not well understood. Well, that depends on how you look at physics. I'm a little offended. It is not clear a gravitational field would be generated or controlled artificially. That's true. What about spinning space stations? Oh no. Dave Hensley says, ask it to write a song in the style of Bob Dylan that answers the question, any physics question I wanted to ask. Okay, we'll give that a shot. Spinning space stations are a common depiction, blah, blah, blah. It's saying it again. It would need to be large enough and spin fast enough to create a noticeable centrifugal force. Sure. While a centrifugal force is fictitious, it does technically exist within the rotating frame of reference. So I'll allow it. The amount of artificial gravity that a spinning space station would generate would depend on size, shape, and spin rate, which is true. How fast would a 1 mile diameter space station need to spin to generate Earth's gravity? What? What happened? I think I broke it. Should I refresh? Scroll down to the bottom of the conversation. There we go. Whew, that was close. All right. Correctly converted to meters. We need to spin at a rate of about 7.2 revolutions per minute. It did the calculation. Not bad. Not bad. And it's outlining exactly how it did it. You know, I'm really glad that I'm not a classroom teacher anymore. Having to adapt the entire structure of my class to account for the existence of these things, that is a huge overhaul. I do not envy teachers right now going into the winter semester. Oh, it said it and we lost it. I think it's having issues. It was outlining the whole thing and then it broke. And it's gone. Bummer. Come on. Okay. So, let's see. I think we're going to go for another 10 minutes or so, and then I'm going to call it. But I want to make sure I get this Bob Dylan question in here because this is going to be fun. It changed its answer. Huh. Oh, I changed it to revolutions per second, which, I mean, 7.24 divided by 60 is not 1.41. So this is a different answer than it gave me last time. But I would have to I'd have to double check it. This is nice though. All right, Bob Dylan question. Cloudflare issue. Yeah, so reloaded it, it's fine. All right, let's see. Let's pick out a physics question. Can you explain what why the acceleration due to gravity is constant across Earth's surface, but as a song in the style of Bob Dylan? Glad there's a spell check here. Sure, here's a short song in the style of Bob Dylan. Oh boy. A lot of people are going to have to adapt to this. I mean, just because it's giving lyrics and it's giving lyrics in a specific style doesn't mean the song's any good. Oh, wow. Okay. Wow, I'm just a simple physicist trying to understand the mysteries of the universe and the forces that command. Wow, this is I can hear Bob Dylan's voice in my head as I read this. This is impressive. See, I'm just a simple physicist trying to understand the mysteries of the universe and the forces that command. My Bob Dylan impression is horrible, but you're going to have to live with it. Gravity is such a strange force. It pulls us to the ground, but why is it constant? All over this round ball we found. Wow. I am impressed, right? And I think this goes back to, I think it was Acapella Science that said this on Twitter recently, is that, like, you know, we all have creative jobs, you know, and I think all us, like, YouTubers and stuff, and I think that, like, it's gonna be, we're just gonna have to, like, make stuff that AIs can't make. You know, there's always going to be things that, you know, it can't do or can't do well. And we just have to figure out what it is, you know, and maybe, like, you know, we can, if this technology improves, we can, like, offload the more tedious stuff. And, you know, I think we'll adapt. It'll be okay. I'm not too worried about it. It is a little freaky, but I'm not too worried. This isn't the apocalypse or anything. Sing, sing, sing. The last time I sung on my YouTube channel, it was the most embarrassing thing I actually put out. I don't think it's public anymore. But I found I was playing around. They had just, I think they had just added the music library for YouTube creators. And I decided to just mess around. It was back in my early experimental days on YouTube, and I decided to mess around and I wrote a song called Ode to Energy. It was so bad. I'm not a musician. And so maybe one of these days I'll one of my friends, his name is Jesse. He's a musician, and he wrote a song once about conservation of energy for his classroom. He's also a physics teacher. And it was really good. He came in and played it on, what did he play it on? Was it a ukulele? It might have been a ukulele. But it can be done, right? Jingle physics can happen. It's just not my skill set. Let's see. Wootik says, I had it make audio by having it write a Python script making each note for Super Mario. Like I've seen people use this to code like a MIDI file, which is just a bunch of like, tower speaker notes, like just frequencies and stuff. Very basic sound file. And that's been successful for people. You might have to tweak the code a little bit. Sometimes it likes to add extra code in that's not necessary. But yeah, it works, right? It actually does work as long as it's in a simple thing that it can understand, like code. It's not going to create the audio file for you, but it will do it. I have seen it done. Let's see. It says ChatGPT is bad at math. Can't even do proper arithmetic with 5 digits. Well, that's it. But the thing is, like, computers might be good at math mostly until you get floating point numbers get weird. There's weird gaps in the number line. But even though computers generally can do math well, this particular software is designed, it's not designed to do math. It's designed to have a conversation. If you're going to do math, you use a calculator, you use a different tool. This is a tool for a specific purpose. And so that's just something to keep in mind there. So it might be bad at math. Like I said, it gave me 2 different answers when I asked the question 2 different times. And so I think we just have to be careful about, what AI is being trained on, and that things aren't like being stolen from people, which is the problem with a lot of the AI art that is going around these days. Someone said, when can it do my taxes? That'll never happen. H&R Block will never let that happen. All those things, H&R Block, TurboTax, they all lobby the U.S. government, at least the U.S. government, for to keep taxes complicated so they can stay in business. So taxes will never be easy. It's not a thing. Computer used to be a job, now it's a machine. Yeah, so like that's the thing. That's how our society changes, right? I mean, we automate a particular task, and then we just have to make sure that when those people are, well, we got 2 options, right? We can either make sure the people that are losing their jobs are trained and put into a different job, or, call me crazy, we can just stop assigning the value of a person to the job they're doing. Just a thought. We used to use horses to travel around, and now horses are more of a niche thing, niche thing. There are a lot fewer horses now than there used to be. I would rather that not be the direction that the human race goes, but I don't know. And so this isn't AI's fault. The existence of the AI is not the problem. It's how society looks at people. That's the real problem here. If we looked at people better and we valued people better, I think that these sorts of changes would not really be that big of a deal. All right. Anyway, I think I'm not getting political. I'm getting sociological. But obviously everyone has their own opinion, and that's fine. But I'm allowed to have mine. It's you know. All right, so it's 3:30 for me. It's an hour and a half. I think that's a good time to stop. Thank you for the very active chat. This was I had a really good time. Let's switch this back. All right. So I had a really good time today. This turned out better. I've been worried about this for a week. I wasn't sure how this was going to go. And so I'm very pleasantly surprised. You were all very very civil in the comments, which, my comment section is always really civil, and I appreciate that, given the dumpster fire that the internet can be. So thank you all for being great, and thank you all for showing up. This was a good time. I'm sure we'll do another live stream at some point this year. Not like overly, like a lot. I'm not doing these once a month or anything, but definitely again in 2023. But on that note, I'll see y'all later. Have a good rest of your day, good rest of your weekend, good rest of your night, if that's your time zone. And yeah, thanks.